In this video, we're going to learn how to solve for trig ratios. And for most of you, I'd imagine this is your first time doing anything with trigonometry. So what is trigonometry? Well, trigonometry is the relationship between the angles in triangles to the sides of those triangles. So pretty much like if you know something about maybe you know one side and one angle in a right triangle, how can you figure out the rest of it? And one thing to keep in mind with this is that if two triangles have the same three angles, in this case we have 53, 90, and 37, both of those triangles, then those two triangles are going to be similar. And if you remember similar triangles, that deals a lot with fractions. So like in this triangle on the left, we could take 12 over 15, and we know that it's equal to 4 over 5, because the ratio in similar triangles has to be the same. Where this gets a little bit confusing is how do you know exactly which numbers work in the ratio? Like how do we know 12 over 5 equals 4 over 5 instead of 3 over 5? In this case, we can kind of just tell from the picture, but once we start getting triangles with different orientations, it could get confusing to write out mathematically. So one thing we could do is we could identify the sides. So the way we're going to do this, we're going to do it in regards to an angle. So the first question I have here is what side is opposite of angle x? Well, if you go to angle x, if you go across the triangle, opposite of angle x in this case is going to be a. So opposite just means you have to go across the triangle. What adjacent means, and this might be a word you've seen outside of math class, it gets used sometimes, it means next to. So whenever you see adjacent, you have to think next to. So what side is next to angle x? What side is adjacent to angle x? Well, from angle x, we kind of have two choices here. It could be B or C. They're both right next to the angle. And the way we figure out which one's adjacent is we don't use the hypotenuse. The hypotenuse gets its own label. So in this case, C is the hypotenuse because it's across from the right angle. B in this case is going to be left to be the adjacent side. So from angle x, A is opposite of it, B is adjacent to it, and C is the hypotenuse. One thing to keep in mind with this too is that these relationships only work from angle x. If I was to change this x to a y, all of a sudden B is opposite of y. So this opposite adjacent hypotenuse label, they work, but only from angle x. And as I said before, with similar triangles, which trigonometry kind of builds off of, the ratios are what really matters. So we have three words to represent the three different types of ratios. If you were to take the opposite over the hypotenuse, that is going to be called the sine. The cosine is going to be the adjacent over the hypotenuse, and the tangent is going to be the opposite over the adjacent. And one mnemonic device that gets used for this is over here, SOHCAHTOA. SOHCAHTOA, this means sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. Sometimes I see people write it like this, where it's S-O-H, and you put the O and the H on top of each other. And then so CAHTOA, C-A-H, you just put the A and the H on top of each other. So this first question here is just asking for the sine of angle x. Well, the sine is the opposite over the hypotenuse. So in this case, from x, A is the opposite, and C is the hypotenuse. So the sine of angle x is just A over C. All you do is you take the opposite side and you put it over the hypotenuse. The cosine of angle x, well, cosine is the adjacent over the hypotenuse. So you say, what side is adjacent to x? Well, that's going to be B. So B is going to be our numerator. What side is the hypotenuse? That's C. So C is our denominator. Cosine is the adjacent over the hypotenuse. And then finally, tangent, so CAHTOA, T-O-A, tangent is going to be the opposite over the adjacent, which in this case is just going to be A over B. So this first question here, it asks for the sine of angle A. You're always going to see an angle with these trig functions. So sine, what comes next is going to be an angle. So in this case, when it's saying sine of angle A, all this is asking is what side is opposite of A and what side is the hypotenuse, and it's going to want you to write them as a fraction. So A is down here. Opposite of A, if you go across the triangle, is going to be 24. Remember, you have to go from the angle here. So across from this A, opposite of this angle in the problem is 24. And the hypotenuse is across from the right angle. The hypotenuse is 30. So the sine of angle A is just 24 over 30. The last thing you have to do for this, though, is you do have to simplify fractions. So 24 and 30, they're both divisible by 6. So when you divide them both by 6, you get 4 over 5. So the sine of angle A is 4/5. The next problem asks us to do the cosine of angle C. So we find angle C, which is down here. Cosine is the adjacent over the hypotenuse. So adjacent to C, next to C, could be 15 or 25, but remember 25 is the hypotenuse. So adjacent to angle C, next to angle C is going to be 15. Meaning the cosine of C, the adjacent over the hypotenuse, is 15 over 25, which simplifies to 3 over 5. The last example is to find the tangent of angle A. So we need to find what side is the opposite of angle A and what side is adjacent to angle A. Remember, you have to go from angle A. If you go from angle C or angle B, the answer is not going to work. So from angle A, opposite of it is 30. So 30 is the opposite. Adjacent to it, we're not going to use the hypotenuse. That's always reserved. We use the 40. So the 40 is going to be adjacent. Meaning the tangent is opposite over adjacent. That's going to be 30 over 40, which simplifies to 3 over 4.